me just. I actually don't have Zoom Pro, so today's meeting will be cut short slightly. So now, let's just wait for like 30 more seconds, and then I'll start sharing my screen, and then we can all start working on all the problems. All right, so it looks like about everyone is here. So let me just start. Oh, by the way, this class is recorded, and now let me just start my presentation. So once again, today's meeting will cover an introduction to algebra problems. It was in AMC problems number 15 to 25. So although since they're earlier years, they'll be easier than what you generally will see within the AMC series nowadays. Like the 2021 version will probably be harder than the problems we're doing right now. It is just a warm-up, or an introduction rather. And if you feel that this class is too easy or too hard, please let me know. And if you think I'm going too fast or too slow, once again, please let me know. Right? So problem number 1. In order for Mateen to walk a kilometer in his rectangular backyard, he must walk the length 25 times or walk its perimeter 10 times. What is the area of Mateen's backyard in square meters? All right, so it looks like about everyone has joined. So he has a rectangular back. Oh, okay, this is pretty. Let me just admit everyone else, and all right. Sorry for my drawing. So basically, this is what Mateen's backyard looks like. Essentially, what we have is a backyard. So we have a length, and we have a width. Sorry for that. So he either must walk the length 25 times to reach 1,000 meters, or he can walk the width, or he can walk the perimeter. Sorry, what was it again? Walk the perimeter 10 times. So here we can just write an equation about this. So we have 25L, where L represents the width, is equal to, so the perimeter is equal to 2L plus 2W. Sorry about this. Next week, I'm definitely getting a pencil for sure. Or I'll try using like something other than my mouse to write. Sorry about this. Okay, so then now we have, he must walk the perimeter 10 times. So we would have 10 times what is a perimeter? That would be 2L plus 2W, where L is the length, W is the width. All right, so let's expand. So can anyone expand, or can anyone tell me what the right side says? Or can anyone just expand the right side and put it in chat or talk out loud? Right. So it looks like people do agree. This is, so we basically get 25L. 25L is equal to 20L plus, oh sorry, let me omit everyone again, plus 20W. So now let's subtract 20L from both sides. We would get 5L is equal to 20W. So we get the ratio between L and W is basically 1 length is equal to 4 times the width. Now what can we do with this information? Since we know what the length is in terms of the width, we can substitute this back into the equation. Because we've left out one crucial part. So this is equal to 1,000 meters. We're actually not going to use that fact that he just uses 1 kilometer, because the answer's in terms of square meters, so it will be better for us to just use meters. All right. So we have 25L is equal to 1,000. So if we just divide 1,000 by 25, then we get that L is equal to 40. Right, so if L is equal to 40, then what is W? That means W is equal to 10 meters. We can check by this fact by substituting these variables into this part. So you have 1,000 is equal to 20L plus 20W. So we would just get 20 times 40, which would give us 800, plus 10 times 20, which would give us 200, is indeed equal to 1,000 meters. So can anyone tell me what the area is? Now we know the length and width. Oh, oops, that was terrible. 400 square meters. Good job. It is indeed C. All right, now let's continue on with the next problem. By the way, does anyone have any questions about this problem? Because if you do, please private message me. All right, okay. So it looks like no one has any questions. So now let's continue onwards. So for the second problem, we have this, where an operation mystery is defined for all non-zero numbers by AXB is equal to A squared over B. So this is a fairly simple problem. You just use this function and plug this in. All right. So let's zoom in a bit so it's easier to see. So we have this, right? So now let's first determine what this is on the left-hand side. On the left-hand side, we have 1x2. Plugging that in, we would get a squared, which is 1 squared, over b, which is 2. All right. So this would give us 1 over 2. So now we have 1 over 2 x3. This is what we have on the left-hand side. So what would this be? So we once again have a squared over b. So this would be 1 over 4 over 3. But can anyone tell me what that is equal to?
3 over 4. 1 over 12.
All right, so we all agree that this is equal to 1/12, right? So now we have 1/12 on the left-hand side minus this expression. Let me actually change color so it's easier to distinguish to something like dark green. Why not? All right, so now we have minus 1 x 2x3 in parentheses. So with this 2x3 we would have this. 2x3 is equal to 2 squared over 3, which is equal to 4/3. Now we have 1x 4 over 3, so that would give us 1 squared over 4/3. Now can anyone tell me what this expression is equal to? Please put it in chat. Yeah, 3/4. Good job. So this is equal to 3/4, right? So now we have 1/12 minus 3/4. So now let's solve this. So if we want to simplify this equation, then we would have 1/12 minus 9 over 12, right? So what is 1 over 12 minus 9 over 12? Can anyone put that in chat? Negative 2/3. All right. All right, good job. So this is equal to negative 2/3. That is indeed the answer to the second problem. All right, now let's continue on to the third problem. Homer began peeling a pile of 44 potatoes at the rate of 3 potatoes per minute. 4 minutes later, Christian joined him and peeled at the rate of 5 potatoes per minute. When they finished, how many potatoes had Christian peeled? So this is another typical type of AMC8 problem where you basically have A can do something at this rate, B can do something at this rate, maybe they have a C can do something at this rate, and then when they finished, how many potatoes did this person peel? All right. So first, let's start with Homer. Homer began peeling a pile of 44 potatoes at a rate of 3 potatoes per minute. Minus. All right, so he has 4 minutes undisturbed where only Homer is peeling potatoes. So in those 4 minutes, how many total potatoes has he peeled? Right, 12. So he peels 12 potatoes, which is equal to 32 potatoes. All right, so now we have Christian who joins him, and he peels at a rate of 5 potatoes per minute. So Homer peels at a rate of 3 potatoes, Christian peels at a rate of 5 potatoes. So combined, how many potatoes do they peel per minute? Here we can just add their rates together. 3 potatoes plus 5 potatoes means they peel 8 potatoes per minute together. So if we have 32 potatoes, 32p, sorry, and then we also know that their rate is 8p per minute. Then we can do something like this. 32p over 8p per minute. The potatoes and potatoes cancel out. 32 divided by 8 would give us 4. So we have 4 over 1 over 1 minute over 4 over 1 minute. So this would just give us 4 minutes. So doing something like this where you set up an expression where you have a unit and then you have a rate, then you can get the total time that was spent peeling. All right. So they spent 4 minutes peeling after Christian joined. So in these 4 minutes, how many potatoes did Christian peel? Keep in mind that he peels at a rate of 5 potatoes per minute. 20. Good job. So it looks like most people agree it's 20 potatoes. So in those 4 minutes that Christian joined him, he peels at a rate of 20 potatoes. Good job. All right. So now let's continue onward to a somewhat less typical problem. Car M traveled at a constant rate for a given time that is shown by the dashed line. Car N traveled at twice the speed for the same distance. So graph problems, I don't believe they're too common on the AMC8. Of course, the MAA committee could prove me wrong and just give us like 10 graph problems for this year's AMC8. However, what is crucial for this problem is using speed. So problems that involve rate, that involve speed, those are pretty common on the AMC8. So it's great to learn and practice a variety of types of problems like these and learn how to attack them. All right. So we have car M that travels at a constant speed. Let's call the speed V. Now we have car 2. So let's actually call it Vm. And the speed of car N is Vn. So the reason why I use like V instead of S is because it's common to use V as a placeholder for speed because it represents velocity, which will be used in physics a lot. So if car M and car N's speed are shown as a solid line, which graph illustrates this? So they travel for the same distance. However, we know Vn is equal to 2 Vm. Right? So Vn is equal to 2 Vm. Then that means that Vn, or at least n, should be twice the amount of m in terms of the y-axis, which represents speed. So let's look at this process of elimination. Let me zoom out slightly and let's look at this problem. Right. So if we know Vn is equal to 2Vm, then we can cross out this, right? Because here we can get that Vm is actually equal to 2Vn, which is wrong. It should be the other way around. Similarly, we can also cross out E. So now that's nice and dandy. But now we have a second crucial piece of information, is that they travel for the same distance, d. So while on the graph we don't have distance, right? We only have speed and time. So however, we can find the time it takes for car N and car M to travel. So time is equal to distance over speed. So if you ever looked at a triangle, it looks something like this, right? I think your teachers in school might have talked about this. D is distance right here, V for speed, and T for time. So basically what this graph means is that there are three crucial equations for distance, speed, and time problems. So D equals speed times time, velocity is speed is equal to distance over time, and time is equal to distance over speed. So in this case, we can make use of the third equation. All right, so let's look at the time it takes for car M to travel distance D is equal to D over, it looks like lots of people are talking in chat. All right, is equal to D over Vm, and now Tn is equal to D over 2Vm. So in fact, let's actually erase this because that takes up a lot of space. And now let's change color since green is getting a bit bland. All right, so we can write Tm in terms of Tm. So Tm is equal to 2 times Tn. We get this because of their denominators. 2 times D, 2 times this, is just equal to this. So in other words, we get that the time that M spends should be twice the amount of time that Tn spends. So where do we get something like this? Oh yeah, everyone is saying that velocity has direction, right? So yeah, velocity isn't the same thing as speed. Velocity is magnitude. It's just a common practice to use v when you were talking about speed, because yeah. So it looks like most people agree the answer is D, because in here the time that car N spends is half the time that car M spends. All right, good job. Now let's move on to the next problem. So let me zoom in a bit. Gage skated 1 hour and 15 minutes each day for 5 days, and 1 hour and 30 minutes each day for 3 days. How long would he take to skate the ninth day in order to average 85 minutes of skating each day for the entire time? So this problem, I actually want you to try it by yourself. Shouldn't be too difficult. So let me actually give you a slight hint before I start this problem. So he has a total of, so initially he skates 1 hour and 15 minutes each day for 5 days, 1 hour and 30 minutes each day for 30 days. So let's just make a slight chart. All right. So initially 1, 2, 3, 4, 5. These are the days he spent essentially 75 minutes to skate. And on the other days, let's change to black. 3 days, he skates for 90 minutes instead. How long would he have to skate on the 9th day in order to average 85 minutes? All right, so 9th day, let's use a bright green color, why not? So when you want to average this, you basically get 75 minutes, 75 times 5 plus 90 times 3 plus x over how many total days it is, 9, is equal to 85 minutes. So let's see if you can all solve this equation by yourselves. Give you like 1 more minute because apparently I can't move it. All right, so I'll give you everyone like 30 more seconds. Looks like some people, yeah, most people have an answer. All right. Okay, good. So it looks like everyone agrees that is E. So let's just check. All right. So we have 75 times 5 plus 90 times 3 plus x is equal to 85 times 9. So from here, let's just do this. 75 times 5 plus 90 times 3 plus x is equal to 85 times 9. Oh, oops. I ran out of space. 9 is right here. All right. So what we get when we multiply 75 by 5, we get 375 plus 270 plus x is equal to 765. So if we were to add this up, we would get 375, 5, 4, 645 plus x is equal to 765. Looks like x is 120 minutes. Good job. Yeah, so for the AMC 8, you generally would have to do this using, well, mental math, I suppose, because it's you can't use a calculator unless, of course, the rules change and then, okay. However, yeah, people are right, you can use scratch paper. So now let's look at the next problem. Miki has a dozen oranges of the same size and a dozen pears of the same size. Miki uses her juicer to extract 8 ounces of pear juice from 3 Miki used her juicer to extract 8 ounces of pear juice from 3 pears and 8 ounces of orange juice from 2 oranges. She makes a pear-orange juice blend from an equal number of pears and oranges. What percent of the blend is pear juice? So now we're moving on to a slightly different topic from instead of the distance rate speed, we're now moving on to percentages. All right. So this is also a pretty typical AMC 8 problem where you essentially just have to deal with just algebra. So she has 12 dozen, yeah. So she has a dozen oranges and a dozen pears. So if she has a dozen oranges and for every if she has a dozen pears and for every 3 pears she gets 8 ounces of pear juice, then we can do something like this. So we have 8 ounces over 3 pears, and now we have 12 pears divided by 8 times, not divide, of course, my bad, times 8 ounces per every 3 pears. So this would give you, we can cancel out pairs, and now we have 12 over 3, which would give us 4, which would give us 32 ounces of pear juice. And now let's look at oranges. So once again, she has 12 oranges, and for every 2 oranges, she can get 8 ounces of pears. For every 2 oranges, she can get 8 ounces of orange juice, not pear juice, of course. That would be pretty miraculous if you could get pear juice from oranges. So now we have 8 ounces per every 2 oranges. So once again, we can have oranges and oranges cancel out. 12 and 2 cancel out to give us 6, so we get 48 ounces. All right. So what percent of the blend is pear juice? So we have 32 ounces of pear juice, 48 ounces of orange juice. Can anyone tell me the percentage? Yeah, so it looks like most people agree it's B. All right. Just to clarify in case people didn't get it, so we have 32 ounces of pear juice over. How many total ounces of total juice will she have? She has 32 ounces of pear juice plus 48 ounces, which should give us 80 ounces of juice in general. So this would just cancel out. So you can divide by 16 to get 2 over 5, which is equal to 40%. Nice, good job. All right, let's look at our next problem. So Loki, Mo, Nick, and Ah are good friends. Ah had no money, but the others did. Mo gave Ah 1/5 of his money, Loki gave Ah 1/4 of his money, and Nick gave Ah 1/3 of his money. Each gave Ah the same amount of money. What fractional part of the group's money does Ah have now? So this problem is, although it might not seem too similar to the last problem, it actually kind of is. Because we once again are dealing with fractions, although it's not a percentage in this case. So let's say this. Loki has an L amount of money, Mo has an M amount of money, and Nick has an N amount of money. So Mo gave Ott 1/5 of his money, so M over 5. So that's the amount of money Mo gives. Loki gives Ott 1/4 of his money, L over 4, is equal to Nick gives Ott 1/3 of his money, N over 3. They're all equal. It says so right here. So how can we use this equation to solve for the amount of the group's money that Ott has right now? So in total, since Ott has no money, then the total amount of money in the group. Oh, okay, right, yay. The total amount of money is equal to L plus M plus N. So how can we find the total amount of money that Ott has right now? Well, he has M over 5 plus L over 4 plus N over 3. Additionally, we can find a ratio between all of these. So let's multiply this whole thing by 120. And let me also change color while doing so. It's kind of getting boring just seeing black. All right, so M over 5 times 60 is equal to 12M is equal to 15L is equal to 20N. So basically what this means is that for every so basically this is a ratio between them. So what this means is that for every M amount of dollars, then L would have 15 over 12M, and and Nick would have 20 over 12M. All right. So this is a ratio. And now we know that this is a fraction of the money that Ott has right now. Never mind. Sorry. There's actually an easier way to go about approaching this problem where you don't have to use a ratio. Sorry about that. I should have just done this right round. So basically we can take this entire thing and divide by M plus L plus N. So basically what we're doing here is, if we look at the numerator will sum up to 12M plus 15L plus 20N is equal to 5 times 4 times 3, which is equal to 60 over m plus L plus n. So what will this give us in total? So this will give us 12m plus 15L plus 20n over in total would be 60m plus 60L plus 60n. So how much money does this mean? Alright, sorry. How much money does have right now? So we essentially have this. So it looks like there are some people who are debating between B and C. Alright, let's check. So now we have this, right? But we can't really simplify this. So now this is where we get our handy dandy ratio from before, where we have 12m is equal to 15L is equal to 20n. So what if we write everything in terms of m? So here we just get m. Let me change color once again, so it's kind of distinguishable. Now we can just erase this part since we no longer need it. All right. So here we would have m is equal to 5L over 4 is equal to 5n over 3. Wait, sorry. So essentially what this, wait, sorry. There's actually an even better way to do it. So L over 4 is equal to m over 5. So then L is equal to 4m over 5. We also know that n over 3 is equal to m over 5. So then n is equal to 3m over 5. So then if we just substitute these two values, what will we get? Well then, let's find out. L is equal to 4m over 5. So 15 times 4m over 5 is equal to, can anyone tell me? Yeah, 12m. So this is equal to 12m plus 15 times 4 over 5 is equal to also 12m plus, all right, 20n, 20 times 3 over 5, which would also give us 12m. This shouldn't come as a surprise. After all, they gave the same amount of money. Now, let's just write the denominator as in terms of m. All right, so we have 60m plus 60L times 4 over 5. So that should give us 48m plus 60 times 3 over 5. That should give us 36m. Sorry, I'm running out of space right here. So let me just erase this once again. So can anyone tell me what the total fraction is? All right, so it looks like most people have gotten B, so let's check. 36m over 60 plus 48 plus 36. That would just give us 60 plus 84, which would give us 144m, and this is equal to 1/4. So that's our answer, B. So this is slightly challenging, but a pretty nice problem. So now let's look at the next problem. Two 600 milliliters pitchers contain orange juice. One pitcher is 1/3 full and the other is 2/5 full. Water is added to fill each pitcher completely. Then both pitchers are poured into one large container. What fraction of the mixture in the large container is orange juice? So now I want everyone to try to solve this problem on their own. We just went over several problems involving fractions and solving problems using fractions. So I hope people can try this and successfully attempt this on their own. All right, I'll give everyone 30 more seconds. Seems like some people have gotten an answer. Some people are saying it's C, some people are saying it's E, so let's see. What a nice pun. Let's see. All right. So one pitcher is 1/3 full and the other pitcher is 2/5 full. So there's actually since we know that these two pitchers are the same size, there's actually a slightly easier method to do this. But first, let me talk about the more, it's not necessarily more rigorous, but the slightly longer solution because it's good practice. So we have one pitcher 1/3 full of orange juice. So 1/3 times 600 is equal to 200 milliliters of orange juice. The other is 2/5 full. So you have 2/5 times 600 is equal to 240 milliliters of orange juice. So if we were to add these two together, we would get 440 total milliliters of orange juice over 1,200. So if we were to cancel this out, this and this, then we would get 44 over 120 divided by 4, we would get 11 over 30. So basically what we did is found the total number of oranges in container 1, found the total number of oranges in container 2, added them up, and divide by the total amount of space, or the total volume of the two pitchers combined, which would be 1,200 milliliters. So now, this one I suppose would be the safer solution because generally the two pitchers might not necessarily be the same size. One might be 300 milliliters, one might be 900 milliliters. So this would be the solution you would use then. However, and that's why I wanted to talk about this solution first. But the second solution is basically using the fact that these two pitchers are the same. And basically what we do is take 1/3 plus 2/5 over 2. So this would give us 5 over 15 plus 6 over 15 over 2. That would give us 11 over 15 over 2, which is 11 over 30. The reason why we can do this is because the two pitchers have the same volume. So so basically what we're doing is we're getting rid of the times 11 times 600 right here, remember? So originally I basically did 1/3 times 600 right here, and 2/5 times 600, 600 right here, times 2 times 600. If we were to multiply this out, we would once again get 200 plus 240 over 1,200, but since they're all the same, I can just cross it out and just do this. So that's a slightly shorter solution. Yeah, so it's C. Nice. So let's move on to another type of problem. The results of a cross-country team training are graph below. Which student has the greatest average speed? So once again, let me remind you that speed is equal to total distance over total time. So in order for the speed to be greater, let's write an equation right now. Actually, let's just use S since it might get a little confusing if I use V. So S is equal to S is equal to distance over time. Yeah, so it looks like most people agree on the answer, so let's check. Speed is equal to distance over time. So what we want to do is that speed and distance are directly proportional, which means that if distance becomes greater, then speed becomes greater. For example, if distance would be equal to 5d, then speed would be equal to 5s. However, if t were to become bigger, for example, if t were to become 5t, then speed would be distance over 5t, which would give us speed over 5. So basically what that means is speed and time are inversely proportional. So when speed becomes greater, time becomes smaller. When time becomes greater, speed becomes smaller. So we want to find a min-max scenario. So we want to maximize distance, minimize speed, and that would give us Evelyn, E, as our answer. All right, so it looks like we still have some problems to go over. So now let's look at another problem. A company sells detergent in three different size boxes, small, medium, and large. The medium costs 50% more than the small size and contains 20% less detergent than the large size. The large size contains twice as much detergent in small size and costs 30% more than the medium size. Rank the three sizes from best to worst to buy. So by that, it means the cost and volume ratio. So we want the smaller cost for a bigger volume. All right. So once again, I'm leaving this problem up to you all as an exercise to the reader. So I'll give you like around another minute. Depends on if more people get an answer, and then we'll talk. All right, so it looks like most people agree that it's E. So let's see. Is it E? All right, so let's define something like this. So the cost, right? So first let's say this. We have C, cost S, cost M, and cost large. And now we also have size. So we have small. S represents small. We also know that the large size contains twice as much detergent. So that means 2S amount of detergent. And the medium contains 20% less detergent than the large size. So that basically means 0.8, 80% of 2S, which is equal to 1.6S. So let me rewrite this as 1.6S. All right. So now we have the volumes or the amount of detergent down pat. So now let's look at the cost. So what is the cost of a small size? We have CS, right? So the medium size costs 50% more than the small size. So this would be equal to 1.5 times C. Let's just call the cost of the small size C. So 1.5 C. And now the large size contains twice as much detergent and costs 30% more than the medium size. So essentially this costs 1.5 times 1.3 C. So now let's find the ratio. So for the small size, we have cost to size ratio C over S. For this one, we have 1.5 C over 1.6 S. And by the way, we're trying to find the smallest fraction because we want to min-max cost and size. So the minimum cost, maximum size. So here we would have 1.5 times 1.3 C over 2S. Now let's see, which one is the best one? So this would just give us a ratio of 1. So this would give us a ratio of 1.5 over 1.6. And this one should give us a ratio of 1.95 over 2. So essentially what this means is that medium 1.5 over 1.6 is less than 1.95 over 2 is less than 1. So it looks like you all are all correct. Good job. That was a pretty fast solution. All right. So it looks like you are also well prepared for next week's lesson, which will be harder AMC problems in algebra from like recent years. So now let's look at this problem. An aquarium has a rectangular base that measures 100 centimeters by 40 centimeters and has a height of 50 centimeters. The aquarium is filled with water to a depth of 37 centimeters. A rock with volume this is then placed in the aquarium completely submerged. How many centimeters does the water level rise? So this problem is also slightly related to fractions. So I also want everyone to try this problem, but first I'll give a slight hint. Let me just change colors back to purple, why not? All right. So we know the volume of our aquarium is 100 centimeters times 40 times 50. Right. So we also know that, in fact, that is not filled up to 50 centimeters, but rather to 37. So a rock with volume 1,000 centimeters is then placed in the aquarium. So let's draw something like this. This is our aquarium. All right, this is actually pretty bad. Let me just do this. Oh, oops. Sorry, my screen just rose, so it's kind of laggy. So now let's draw an aquarium that looks something like this. Originally, the water level is right here, 37 centimeters. However, we then place a large rock inside. So that basically means that this rock occupies some volume. What is the volume, you ask? Well, the volume of the rock, V, is equal to the length times the width of the base of the aquarium, since the aquarium is actually rectangular. So it looks like that, and then like, of course, rest of the rectangular aquarium. Yeah, it doesn't look that good actually. So now times height. The height is the something that we're trying to find, the height of the water displaced. Because the water, since we have something new here, gets displaced to a new level right here. That's in light green. So what is this difference in height? That's what we're trying to find. Ah, great. Looks like my laptop just froze again. All right, okay. So everyone can see my screen now, right? Hopefully. Okay, yeah. Looks like people can do it. All right. So now let's just see. I'll give you all like 30 more seconds to do this problem since it looks like some people have gotten an answer already. All right, so it looks like most people agree. So let's see. So we know the rock with a volume 1,000 centimeters cubed is equal to the base times width of the aquarium, 100 times 40 times the height h that we're trying to find. Now let's solve this equation. So 1,000 divided by 100 would just give us 10. Divided by 40 would give us 1/4 is equal to h. So our answer is indeed A. Good job, everyone. All right, let's move on to the next problem. So this type of problem is basically where you substitute digits for A, B, C, and D. So this is once again another type of typical AMC 8 problem. So let's solve this together then. This is multiplication, keep in mind. So of course I could first say A times D is equal to D. Maybe there's a carryover of 1, maybe. We're not sure. However, there's something very, very nice about this expression. So basically we have a 3-digit number ABA times CD is equal to CD. So of course we could do something like this. We could just straight up bash it, right? So we would have ABA can be represented as 100A plus 10B plus A times 10C plus D is equal to, I'll run out of room, so let me just write it here, 1000C plus 100D plus 10C. Oops, and I ran out of room anyways, plus D. Sorry about that. All right. So so we have like what, 4 unknowns, and we could just straight up bash it. This is how you would typically solve an expression like this, or a problem like this, if you didn't know one crucial information. That CD times a 3-digit number is equal to CD. Basically what this means is that A is equal to 101. ABA is equal to 101. See, there's a special property of 101 such that 101 times any 2-digit number, right? Times any 2-digit number, let's just call it XY, is equal to XY. We can see that, oh, oops, this is pretty bad. XY. We can see this for ourselves here, XY. So let's replace xy with 10x plus y. That's how you would represent a number like that, right? So we can also write this as 100 plus 1 times 10x plus y. Now let's expand this. So you then get 1000x plus 100y plus 10x plus y. And this would equal to xy. Alright, yay! That's great news for us. That basically means that APA is 101, 100% for sure. Alright, so that's very great news. So we can always give a cheer of yay. Alright, so now we are faced with a slight conundrum of what is CD? Because you see, ABA times CD is equal to CD. And this would be a case since we can't tell what CD is. However, we don't really care about CD. We just know ABA is 101, A equals 1, B equals 0, boom, we're done. So what is A plus B? 1 plus 0 is equal to 1. Yay! All right. By the way, you can't really use a calculator for this type of problem. So you either have to notice it or just have to straight bash. So now let's look at this problem. 2006. All right. So Barry wrote 6 different numbers, 1 on each side of 3 cards, and laid the cards on the table as shown. The sums of the 2 numbers on each of the 3 cards are equal. The 3 numbers on the hidden sides are prime numbers. What is the average of the hidden prime numbers? So this is like slightly number theory, slightly algebra, mixed of it together. But since this is a unique niche of algebra problems, I still included it in this handout anyways. So let's see, how do you approach a problem like this? It's pretty troublesome, right? So we would have 44, 59, and 38. So 44 plus x, right on. So let's say the primes are called x, y, and z. So 44 plus x is equal to 59 plus y is equal to 38 plus z. All right, so this seems like a pretty hard thing to do, right? So how would we approach a problem like this? So thankfully we have a very special prime number to thank for this solution, 2. 2 is the only even prime number. And what is the significance of that? So let's consider, for the sake of an argument, that x, y, and z are all prime numbers that are not 2. So that means x is odd, y is odd, z is odd. So essentially what we have is okay. So what we have right here is, let me just get a bright color, right? So you have an even number plus an odd number. So an even number plus an odd number is equal to an odd number. So here we have an odd number plus an odd number is equal to an even number. So we have an even number plus an odd number is equal to an odd number. So this is a technique to keep in mind during number theory. Of course, you probably should use like mods instead to do it, but you can always use the parity of numbers to solve for a solution. And by that I mean that if x, y, and z are odd, then there's no way we can solve this solution, right? Because that means that an odd number is equal to an even number is equal to an odd number. So we can have these two equal, but we can't have it equal to this. So it's a no-go, right? So that basically means that y is equal to 2 for sure. And if y is equal to 2, basically have something like this. Say x and z are prime numbers that are not 2, so that means they're odd. So even plus odd would give us odd. Odd plus even would give us odd, and even plus odd equals odd. So essentially we would get odd numbers all around the board. So that means that y must be equal to 2. So 59 plus 2 is equal to 61. So now we can just find x and z through simple subtraction. What is 61 minus 44? $17, right? So we can agree this is 17, and what's 38 plus z is equal to 61. So 61 minus 38. Can anyone tell me what that is? 23, right? Yeah, good job. So we have 23. So essentially, what is the average? So now we want the average of 17, 2, and 23. 17 plus 2, 19 plus 20 alright, so basically 17 plus 2 plus 23 over 3. So 17 plus 20, oh, that's a terrible 3. 17 plus 23 is equal to 40. 40 plus 2 is equal to 42 over 3 is equal to 14. Yay! What a nice solution. So although we relied more on like number theory for this problem, I still think it's worthy to be included in the algebra handout because it's a nice mindset to always approach with any type of problem. All right. So now let's look at the next problem. All right. So this will most likely be the last problem of today. Let A, B, and C be numbers with 0 is less than A is less than B is less than C. Which of the following is impossible? So now let's look at what we know about A, B, and C. A, B, and C must be positive numbers. Well, they could be like, it doesn't necessarily have to be positive integers, positive whole number, well, positive whole numbers is the same as positive integers, but it can be positive rational numbers. So basically you can have root 3, 2 over 3, 1/5, 5, 7, anything, right? But this gives us one crucial thing. So it means that no matter what, let's say x and y are two arbitrary numbers from A, B, and C. It means that x times y is always positive, and x over y is always positive. Naturally, that also means that if we have A minus B, that would be negative, B minus C negative, B minus A positive, C minus B positive. So what can we conclude about this? So let's go through all of these cases. So A plus C is less than B. Of course this can't be possible, right? A plus C is less than B. Now, if A and C were negative numbers, for example, like -3, -5, and like B was something like -4, this would be possible. But on the alternatively, we know C is greater than B. So it's impossible. So A is our answer. So that was, yeah. So everyone agrees it's A. But I think we can learn more if we approach B, C, D, and E. So why are they possible? A times B is less than C. This is possible. For example, if like A is equal to 1, B is equal to like 1.1, C is equal to like 100, of course, then A times B is less than C, A plus B is less than C, 3, 5, C is equal to 100, A is less than 100, A times C is less than B. So wait a minute. Doesn't this look eerily similar to our answer choice right here? How is this possible? Because what if A, B, and C are all less than 1? So for example, A is 1/2, sorry, A is like 1/10, I don't know, B is like 1/3, and C is like 1/2. So 1/10 times 1/2 is equal to 1/20th is less than 1/3. So that's possible. B over C is equal to A. Is that possible? Of course it is. So if we have like A is equal to 1, wait, no, that actually, A equal 1 can't work. Well, like A is equal to 2, B is equal to, no, sorry. If A is less than 1, so if A is something like 1/2, B is equal to 6, C is equal to 12, then that would work. All right. So these other possibilities are all scenarios that work. So it's 1:30 right now. So before everyone leaves, I want to leave a couple passing remarks. So the video of this class will be uploaded to Alphademic, the website, as well as the YouTube channel. And then I'll be posting this handout. I'll be posting this handout onto our Google Classroom. So sometime during the next week, when you want to practice these problems, see if like maybe you missed a question today, and now you want to do it again for revenge and for honor and for vengeance, then you can attack the problem then at your leisure. All right. So hope you all learned something from today's class. So today was an introduction to algebra, so it was slightly easier algebra problems. So now, yeah. Oh, by the way, you should most likely do the remaining problem. We only have one left as homework. So, and there will most likely be additional homework as well.
On the Google Classroom?
Yeah, right. I'll send out a packet for next week's class before Sunday. So just in case you want to like attack some problems beforehand and you want to do it and compare your answer with mine or your solution with mine to see how our solutions differ, then that's great. So see you all next week. Next week we'll be moving on to harder problems. So if you found today's class a breeze, don't worry, next week it will be challenging. And if you have any criticism of my teaching, for example, too fast, too slow, too easy, don't be worried. You can always message me on Google Classroom. All right. See you guys next week. Bye.
Bye. Thank you.
Bye. Thank you.